Let's say I gave you the point 3 comma 4 in the xy plane, and I said, hey, I want you to find an equation that determines the slope of the line that goes through 3 comma 4 in any other point in the xy plane. So what this means is that this equation will take in, you're going to plug in the x and y coordinates of the point that you chose into this equation, and the equation will spit out the slope of the line that goes through your point of choice and 3 comma 4. So if you want, you can take a minute and figure out what the formula would be. Well, that is, find the slope of this line where x and y, x comma y, is any point in the xy plane. All right, so I'm assuming you've given it a shot. So remember that the slope formula is y2 minus y1 over x2 minus x1, where we can assign x1, y1, and x2, y2, however we want, as long as x1 comma y1 is 1 point and x2 comma y2 is another point. So since y2 is y and y1 is 4, on the top we have y minus 4, and on the bottom, since x2 is x and x1 is 3, we have x minus 3. So our slope of the line that goes through the point 3 comma 4 and any other point in the xy plane is exactly this, where we can just plug in that point x comma y into this formula, and it spits out the slope between of the line that goes between 3 comma 4 and x comma y. Let's first assume here that the point that we chose is a point such that the x coordinate is not equal to 3. And why can we assume that? Well, that would make this slope undefined. That is, we would end up with a vertical line. We would end up with a vertical line if we chose a point such that the x coordinate of that point is 3. So we can assume now that x is not equal to 3. And this means, check this out, you'll see in a minute while we're doing this, that we're safe to multiply both sides of this equation by x minus 3. And what do we get when that happens? Well, we get x minus 3 times m is equal to y minus 4. And let me sort of rewrite this in a way that you've seen before. Y minus 4 is equal to m times x minus 3. And if this isn't ringing any bells, that's okay. Let me replace, remember this 3 comma 4, I kind of just started off with just a random point 3 comma 4. Notice here that 3 comma 4 was our fixed point. It was our fixed point right here, and x comma y was a point that could be whatever we wanted it to be. And the reason we call 3 comma 4 the fixed point in this case is because x comma y is sort of to make it distinct from this point x comma y, which could be anything we want. Like x comma y could be over here, x comma y could be over here, it could be anything. So, but suppose we wanted our fixed point to be something else. Suppose we wanted it to be like, I don't know, 5 comma 2. Then you can check for yourself that if we played this same game here, if we played this same game where we wanted to find the slope of the line that passes through the point 5 comma 2 and any other point that we could possibly want, then we would get this same equation, except we would have, instead of 4, we'd have y minus 2 is equal to m times x minus 5. Now, in general, what happens if we just have any fixed point, an arbitrary fixed point? And mathematicians usually denote an arbitrary fixed point in the following way: x naught comma y naught. So this point x naught comma y naught plays the same role as 3 comma 4 did in this derivation here. So if we wanted to do this same game with the point x naught comma y naught, the fixed point x naught comma y naught, this is our fixed point here, then we would get the following. And I think you can see where I'm going with this. This is y minus y naught is equal to m times x minus x naught. And notice what we have here. We have the point slope formula. The point slope formula.